Hello everyone, I am Dr. P. Kumari, working as Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering. So today in this video, I am going to discuss about volume integral. So in this video, we are going to know about what is volume integral, what is the formula for the volume integral, and what are the applications for the volume integral, and some of the problems we are going to discuss now. So first of all, what is the volume integral? Volume integral is an integral which is evaluated over a volume bounded by a surface. So here we are integrating or evaluating over the volume bounded by the surface is called volume integral. So here nothing but here we can take this one as a triple integral also. Triple integral is nothing but we are going to calculate the volume integral, that is we'll call it as volume integral. So here if we are taking f bar equal to fni bar plus f2j bar plus f3k bar is a vector field in V. So in V we are taking f as a vector field. How we can say that this is the vector field? We are having the ijk direction. So fni plus f2j plus f3k. Then volume integral is defined by, so the volume integral is defined by, how we are taking the formula here, integral over V, f bar t. So here what is the vector we are going to write? So based on that we can evaluate the integral. So what are the applications of volume integral? We can observe here. Volume integrals are especially important in physics for many applications. So for the volume integrals we are having many applications, particularly in the physics. For example, here we can see calculate flux densities. Calculate flux densities or to calculate mass from a corresponding density function. From the corresponding density function, we can calculate the flux densities and we can calculate the mass by using this volume integral. So you can observe these figures, how we can calculate the volume integrals, how the figures will be. So based on this, we can get the more clarity about this volume integral. So here, now we are going to discuss some of the problems about the volume integral, how to calculate and how the problems will be. So we can observe here they given the vector field. What is that? If f bar equal to 2x square minus 3zi minus 2xy into j minus 4xk. This is the vector field. Evaluate triple integral over V del cross f dv. So what we have to calculate? Del cross f dv. Where V is the volume of the region bounded by x equal to 0, y equal to 0, z equal to 0, and they given 2x plus 2y plus z equal to 4. So by using this, we can get the limits of x, y and z, and already we are having the f. So by using the f, we can calculate the del cross f. So by using these values, limits of the x and y and z, then we can integrate the integral. So first of all, we are going to write the given data. So see here, given in the solution we are writing here, given f bar equal to 2x square minus 3z into I minus 2xy into z minus 4xk. So here what we have to calculate? We have to calculate triple integral over V del cross f into dv. So first we have to calculate del cross f value. After that we can integrate the function. So what is the formula for the del cross f? Already we know del cross f is that of I, j, k, dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. So here we can say that this one is the f1i bar plus f2j bar plus f3k bar. So already we discussed in the formula. We can observe here This f bar we are taking as f1i plus f2g plus f3k. So according to that, we can calculate del cross f also, del dot f also, what they are given in the problem. So by using this, we can observe here. So det value is ijk, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So by using this formula, we are writing here del cross f bar. Del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. This is the del operator. So del cross f we are doing here I j k. So I quotient is dou by dou x. J quotient is dou by dou y. K quotient is dou by dou z. And here F1 is 2x square minus 3z. F2 is minus 2xy. F3 is minus 4x. Now we are going to calculate the det value. So here det value del cross F value is I. When you are calculating with I, we have to take this one with the cross multiplication. So I into dou by dou y of minus 4x minus dou by dou z of minus 2xy minus 2xy. Now we are doing with respect to y. So 4 is the constant, x is the constant. So this value is 0. Minus, now I am doing with respect to z. This is minus 2xy. 2 is constant, x is constant, y is constant. So first term is 0. That's why we wrote here I into 0 minus 0. Now we are going to calculate j. So j means, so here j into, so this one with the cross. So dou by dou x of minus 4x. Dou by dou x of minus 4x minus dou by dou z of 2x square minus 3z. So dou by dou x of minus 4x means here j into minus 4 into x derivative is 1 minus dou by dou z of 2x square, that is 0. 2 is constant, x is constant, minus 3 into z is 1. This value is finally j into minus 4 plus 3. This is j into minus 4 plus 3. Now we are going to calculate the k term. We will calculate the k term here. So we have to take this one. So k into cross multiplication dou by dou x of minus 2xy minus dou by dou y of 2x square minus 3z. So here with respect to x we are doing here. So minus 2 and y both are constant, x is 1 minus dou by dou y of 2x square is constant, so 0. 3z also constant, 0. So finally value is minus k into minus 2y. Sorry, plus k into minus 2y. So these are the values of del cross f. Del cross f. Now finally we are simplifying this. So this term is 0. So j into minus 4 plus 3 is 1. So minus j. Here plus k into minus 2y. So finally we are writing j bar minus 2y k bar. This is the value of del cross f. So after calculating the del cross f, we can integrate the function. See here. Triple integral over v del cross f into dv. So this one is triple integral over v del cross f value we got here j bar minus 2y k bar into dv. So to integrate this function we have to know about the volume. So into triple integral v j bar minus 2y k bar into in the dv place we can write dx dy dz. So to calculate this dx dy dz integral, we should know about the limits of x, y and z. How we can take the limits? We are going to know now. So in the question only they given x and y and z values are 0. So in the question they given here x equal to 0, y equal to 0 and z equal to 0. And one more plane also they given. What is this? 2x plus 2y plus z equal to 4. 2x plus 2y plus z equal to 4. That is only we wrote here. For limits we are writing here given x equal to 0, y equal to 0, z equal to 0, and the plane is 2x plus 2y plus z equal to 4. So from this we are going to find the z limits, y limits and x limits. Okay. So here first we will take the plane. So from this I can write the z value, z equal to 4 minus 2x minus 2y. So already I know z is starting from 0. So z is 0 to z equal to 4 minus 2x minus 2y I can take. So these are the z limits. Okay. So after that I am going to put z equal to 0 to get the y limit. So observe here 2x plus 2y plus z equal to 4. Now putting z equal to 0. That implies what it will come here, 2x plus 2y equal to 4. Taking 2 common here, x plus y equal to 2. X plus y equal to 2. Here from this I can write y equal to 2 minus x. Already I know the y value, that is y equal to 0. So y equal to 0 to y equal to 2 minus x. Here that is only we got here, y equal to 0 to y equal to 2 minus x, that is 0 to 4 minus 2x and 2y. So now I put y equal to 0. So here I am giving y equal to 0, then 2x equal to 4. So finally x equal to 2. 2x equal to 4, finally x equal to 2. Already I have x equal to 0 to x equal to 2. So I got the limits now, x equal to 0 to x equal to 2, x equal to 0 to x equal to 2. Now I got the limits of z and y and x. Now I can integrate the, so here triple integral over v del cross f into dv is equal to triple integral del cross f value is j bar minus 2y k bar into, in place of d we can write dx dy dz, dx dy dz, that is equal to here the limits. Already we can write z limits, y limits and x limits. Z and y are varying. So first we have to take the constant limits. So x limits are 0 to 2 and here y limits 0 to 2 minus x. Next z limits are 0 to 4 minus 2x minus 2y. Here in place of f cross, del cross f value is j bar minus 2y k bar into, so first these limits are z limits, so dz. These limits are y limits, so dy. So dy and dx. dy and dx. Now we are going to integrate this one. This is the constant. So that means first we have to do with respect to z. So integral 0 to 2, 0 to 2 minus x. Now j bar minus 2y k bar. So here there is no z terms. That means the constant we can keep it out. Integral 0 to 4 minus 2x minus 2y to dz, and here dx dy dx. So first I will do this integration. After that I can go to next step. So integral 0 to 2, integral 0 to 2 minus x, and here j bar minus 2y k bar into integral 0 to 4 minus 2x minus 2y into dz dy dx. Now here integral 0 to 2, integral 0 to 2 minus x, j bar minus 2y k bar. So this is the constant. So integral dz is z. Limits are 0 to 4 minus 2x minus 2y into dy dx. dy dx. Now this one, so integral 0 to 2, integral 0 to 2 minus 6, j bar minus 2y k bar into, so here we are substituting the limits, 4 minus 2x minus 2y minus 0. So this is dy dx. So first we have to simplify this. Up to this you can observe. So j bar minus 2y k bar. So z into 4 minus 2x minus 2y dy dz. That is only we can observe here. Now here we can calculate the limits. First we have to simplify this value. What is the value we are having here? So integral 0 to 2, integral 0 to 2 minus x. So we are going to multiply this 4 minus 2x minus 2y with the j and 4 minus 2x minus 2y with k. So that one we can observe here, integral 0 to 2, integral 0 to 2 minus x. First we are multiplying with the j. So 4 minus 2x minus 2y into j bar minus 2y into 4 minus 2x minus 2y into k bar dy dx. So dy dx, that is on the step we got here. Now we are going to do with respect to y, after then with respect to x. So here we can observe this integral 0 to 2. First we are doing with respect to y. So y, integral dy is y. Limits are 0 to 2 minus x. Minus 2x is the constant. So integral dy is y. Limits are 0 to 2 minus x. Minus 2 into. So integral y dy. Integral y dy is y square by 2. Limits are 0 to 2 minus x. Minus here 4 2s are 8. Okay. If you want, you can keep like this. So 8 y dy. Y dy is y square by 2. Limits are 0 to 2 minus x. Okay. So here this is the value. It's minus minus plus. Here 2 2s are 4. X is the constant. Integral y dy is y square by 2. Limits are 0 to 2 minus x. Next one is minus into minus plus again here. This one is 2 2s are 4. Y square we are having. So integral y square dy. So y square dy is y cube by 3, So here y cube by 3, limits are 0 to 2 minus x into dx. That is only we are having here up to this part, So we have to do like this. We have to simplify. After then we are doing the integration. So up to second integration, that means up to dy is completed. So one more dx is there. So first we will simplify this one. After that we can move to x. So we can observe here, in place of y we have to replace 2 minus x because y limits are 0 to 2 minus x. So here y into, so 2 minus x minus 0 minus 2x into, in place of y again 2 minus x minus 2 minus x, 2 will be cancelled here. So here y square means 2 minus x whole square into j bar minus, next one is 4y square. So 4 into y square, 2 minus x whole square minus 2x into again y square. Y square means 2 minus x whole square. So here minus 4 by 3 into y cube. Y cube is 2 minus x whole cube k bar dx. So now we are simplifying that. So this one 4 minus 2. So integral 0 to 2. 4 2s are 8 minus 4x minus here 2 2s are 4. 4x minus into minus plus. So 2x square. After that minus 2 minus x whole square is 2 square. 2 minus x whole square is 2 square plus x square minus 2ab. So that means 4 plus x square minus 4x. So here we can write with the minus. So minus 4 minus x square plus 4x into j bar. Now minus here 4 into 2 minus x whole square value. So 4 4s are 4 into 4 plus x square minus 4x. What is this value? 16 plus 4x square minus 16x. That is all we are writing here. So 16 plus 4x square minus 16x. Here next minus, say we have to calculate with the 2x. Multiply with the 2x, same term 2 minus x whole square. We are going to multiply with the 2x. So 2x into 4 plus x square minus 4x. Here plus is there. So 4 2s are 8. So 8x square plus 2x cube minus 8x square. This is all we are writing here. 2x into 4, that is 8x here. This is 2x into 4 plus x square minus 4x. So 2x into 4 is 8x plus 2x cube minus 8x square. This is all we are writing here. So that is minus 8x minus 2x cube plus 8x square plus 8x square. This is the term here. Next we are going to multiply this one. So minus 4 by 3 into. So 2 minus, here 2 minus x whole cube. That is a cube plus b cube minus 3ab. That means 3 into 2 into x into a minus b. So that is all we are writing here. 2 cube. 2 2s are 4, 2 2s are 8. So this is 8 plus x cube minus here 3 2s are 6, 6 2s are 12. So minus 12x plus 3 2s are 6, 6 2 are here 6x square plus 6x square. This is the value we are going to multiply with 4 by 3. So 4 by 3 into 8 plus x cube minus 2x, minus 12x plus 6x square. 6x square. So here this is 24 by 3 plus 4x cube by 3. Here minus 16x and plus 6x square. So that value after simplifying. So this is the value. This is the value. Same what we calculated. Now after simplification here we got 4 minus 4x plus x square for the j, and here 1 by 3 taking the common, so k by 3, 16 minus 24x plus 12x square minus 2x cube. Now we are going to do the integration with respect to x. So here 4 integral dx. 4 integral dx is nothing but 4 into x, limits are 0 to 2. So here 4x minus 4 into here x square by 2. 4 integral x dx. So this is 4 into x square by 2. This value we got here 2x square. We got here 2x square. This is only 2x square. After next term we can observe here integral x square dx. Integral x square dx is x cube by 3. Already we know this formula. Integral x power n means x power n plus 1 by n plus 1. N plus 1 by n plus 1. This is all the value we can observe here. So this is x cube by 3. Next up to j term. Next k. So here we are taking the k bar by 3 into 16. 16 integral dx. 16 integral dx is nothing but 16x. 16x. Next after that 12 integral x square dx. So this is 24 integral dx. This is the term. Next term is 24 integral x dx. So 24 into x square by 2. So 12. So this value is 12x square. Next one is 12x square. Next one is 12 integral x square dx. Now 12 into x cube by 3. So 3 4s are 12. So 4x cube. 4x cube. Last term. What is the last term? Minus 2. That means 2 integral x cube dx. 2 integral x cube dx is 2 into x power 4 by 4. So 2 to the 4, we got x power 4 by 2. So limits are 0 to 2 and here also 0 to 2. Now we are going to substitute the limits. So 4 into 2 minus 0 minus 2 into 2 square minus 0 plus 1 by 3 into 2 cube minus 0. So 4 2s are 8. Here 2 square. So 4 2s are 8. Next here 8 by 3. So this is the first value. Next coming here, plus here minus k bar by 3 into 16 into 2 minus 0. So 16 to the 32. Next minus 12 minus 12 into x square. So 2 square minus 0. So 12 into 4 is 48. Next plus 4 into 2, 2 cube minus 0. So that is 32. 8. 4 equals 32. Next minus 2 power 4 by 2. So that is 8. So we are simplifying now. So 8 minus 8 plus 8 by 3. That means 8 by 3. So 8 by 3. Here this value is 8 by 3 into j. Next one we are going to simplify. Here 32 minus 48 plus 32 minus 8. So 32 plus 32 is 64 minus 48. 48 and 18. 48 and 18 is 16, 56. So 64 minus 56, that is 8. So minus 8 by 3 k bar. So finally we are taking 8 by 3 common. We are getting here j bar minus k bar. This is the final value. What is that final value? That is That is triple integral over v del cross f into dv. That value is 8 by 3 into j bar minus k bar. So this is the final answer. So this is the way to calculate the volume integral. So here we are going to discuss one more example to get the clarity. So I hope you understand the first problem. I am moving to second problem. You can observe here. If f are equal to x square I plus zj plus yzk. So evaluate what we have to evaluate. Triple integral over v del dot f dv. So here where v is the value of the cube. So bounded by, they given the limits here, x equal to plus or minus 1, y equal to plus or minus 1 and z equal to plus or minus 1. So that means x limits are minus 1 to plus 1. Y limits are minus 1 to plus 1. And z limits are minus 1 to plus 1. So these are the x and y and z limits. So in previous problem we calculated del cross f. Here we are going to calculate del dot f. So we should know about the basic formulas. What is the del dot f? What is the del cross f? What is the divergence? What is the grad? So if you know what is the del operator, that only we can do the all problem. So now we are writing the given data. So given f bar equal to x square I plus zj plus yzk. So now we are going to calculate del dot f. So already told you what is the del. Del is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. So now we are doing del dot f. So that means I dot I is 1. So dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. What is the f1? What is the f2? What is the f3? You can write here. So f1 is equal to x square. f2 is z and f3 is yz. Now we are going to replace here dou by dou x of f1 is x square plus dou by dou y of z plus dou by dou z of yz. So dou by dou x of x square is 2x. Next plus dou by dou y of z is 0 plus dou by dou z of yz. So y into z is 1. Finally we got del dot f value is 2x plus y. Here del dot f is 2x plus y. So this calculation, if you know the formula, then only you can calculate. So you should have the basic formulas knowledge. Then only we can calculate or we can solve the problems. Now we are going to integrate the integral here. Triple integral over v del dot f dv. So triple integral over v del dot f dv is equal to, So just now I calculated del dot f value. So triple integral over v. Del dot f value is 2x plus y and dv. So here dv I can write it as 2x plus y into dx dy dz. Now I am going to know about x, y and z limits. So in the problem they give an x and z and y values. So based on that, so x limits are minus 1 to plus 1. Y limits also minus 1 to plus 1. And z limits also minus 1 to plus 1. So we are writing here integral minus 1 to 1, here minus 1 to 1, minus 1 to 1, 2x plus y dx dy dz. Now, so here observe triple integral over v. So that means we are taking the limits here. Triple integral over v del dot f into dv is equal to integral 2x plus y into dx dy dz. dx dy dz. So limits are minus 1 to 1, minus 1 to 1. So minus 1 to 1. So here 3 values, so that means limits of x, y, z. 3 values are constant. So that means we can do any value first integration. We can do with respect to x also, with respect to y also, with respect to z also. So if you are having the variable and constant, then we have to do first with the variable, after that constant. But here 3 are constant. So we can do respect to x also, y also and z also. So here first I am doing with respect to x. So minus 1 to 1, minus 1 to 1. 2 into x into dx is x square by 2. X into dx is x square by 2. Limits are minus 1 to 1 plus y. Integral dx is x. Limits are minus 1 to 1 into dy dz. dy dz. Now this value becomes minus 1 to 1. Integral minus 1 to 1. 2 will be cancelled here. X square. X square means 1 square. 1 square minus 1 whole square. This is the upper limit minus lower limit plus y into here 1 minus of minus plus 1 into dy dz. So this is 0. So finally we got minus 1 to 1, here minus 1 to 1. This term is 0 means here we got 2y dy dz. That is only we got. So up to this step completed. Now we are going to integrate with respect to dy. So integral minus 1 to 1, 2 into integral y dy. Integral y dy is y square by 2. Limits are minus 1 to 1 into dz. Now 2 will be cancelled. Integral minus 1 to 1 y square. That means 1 square minus 1 whole square into dz. So here we got this value is 0. So 0 into dz is nothing but this is 0. So finally we got this value is 0. So final answer triple integral over v del dot f into dv value is 0. So this is the volume of the cube when they are having the limits x equal to plus or minus 1, y equal to plus or minus 1 and z equal to plus or minus 1. So this is the way to evaluate the volume integral. So I hope you got information about the what is the volume integral, what is the application of the volume integral and how we can evaluate the volume integral by using the limits. So here these are the references I used for the volume integral. So here engineering mathematics textbook written by IKV Iyengar and the textbook is written by B.S. Cravel and I used some of the Google links. We can go through to get the more information about the volume integrals. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.